Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This video begins the chapter, another chapter on recursion. I wouldn't say the chapter on recursion. There are actually 3 chapters on recursion in the book. This is the second one. And so in the previous one, we used recursion just to give us iteration. So that was way back in chapter 6. We hadn't learned about loops. We hadn't even learned how to do lists and arrays yet. And so recursion was our first approach at making things happen multiple times. And one of the first programs that we wrote using recursion was we had a function, and we can call it countdown, takes an integer, and what it did was it checked if n is greater than 0, then it would print line n and call itself with n minus 1. Our base case here is implicit. It's the case where n is not greater than 0, in which case nothing happens, and our function has terminated and it will return back up to where it was called. So if we run this, we have to put in a call here. Countdown 5. And so we get 5, 4, 3, 2, 1. Now at the very end of chapter 6, I put in an example where I hinted at something that was more interesting, something that showed a side of recursion that all of the examples that we had done really didn't take advantage of. And so that example code was to take count down, and we're going to convert it to a function called count up. Now of course this doesn't count up right now, but I'm going to make one minor change. I switch the order of those 2 lines and I call it count up. I didn't necessarily have to change the name. Of course the computer Scala has no idea that count up is English for something that counts up. It's just a sequence of 7 characters that happens to match in Scala. So what really mattered was that I switched those 2 lines, and now when I run this, it counts up. And so the question is, what's going on here? Okay, why can this do this? And this right here is something that is going to be significant to us in this chapter, because in this chapter we're starting to explore how recursion is more powerful than simply doing iteration through loops. So in the last chapter I talked about the layout of memory, and I talked about how at one end of the memory that your program gets there's a stack, and at the other end there's a heap. Now you can picture what happens when we call a function as, I'm going to draw this as a stack and I'm going to make it go from left to right, just because that's perfectly valid. In most of the architectures that I've played with, if you actually print out where the addresses are in memory, as one function calls the next the stack grows from right to left. But that's a detail that doesn't matter to us at this point. So when we first called our count up function, we called it with the value of 5. And so we come into here with n equals 5. And when that happens, we get a stack frame. There's a section of memory that's allocated on the stack, and it remembers that n equals 5. And it does a check. It says, well, is 5 greater than 0? And of course the answer is yes. So what does it do next? Well, it calls itself with n equals 1. Now, in calling itself, what happens is we allocate a new, not n equals 1, it calls itself with n minus 1. We allocate a new stack frame. So the first call got a stack frame where it said n equals 5. We're now going to get another stack frame that says n equals 4. Now note, this is a separate n. Every stack frame gets its own value of n. So these aren't conflicting with one another. But also note that nothing has been printed yet. Okay, we called with n equals 5, and before it printed, it called with n equals 4. And of course, what does that do? Well, it checks, is 4 greater than 0? Yes, of course 4 is greater than 0. So it calls with n equal 3. And then that checks, is 3 greater than 0? Of course it is, so it calls n equal 2, which calls with n equal to 1, which calls n equal to 0. Okay. So now we go back to our code, and note that there are now 6 different stack frames that have been pushed onto the stack. They are actually remembering 6 different n values from 6 separate invocations of count up. So if we go back to our code, the 5 called the 4, which called the 3, which called the 2, which called the 1, which called the 0, and then we do the check. 0 is not greater than 0, so it jumps back here and it terminates. And when it terminates, the call stack pops off. So we go back to this state here. But in addition to storing that n was equal to 1, it also stored where it was in the function. And the recursive call happened right here on this line. So when that recursive call is done, it proceeds to the next line. So it calls println n. But what happens there? Well, this calls println n in the stack frame where n is equal to 1. So it prints out 1. And after it prints out the 1, well, it's done and it returns back up the stack. And so the n equals 1 stack frame pops off, and we get to the n equals 2 stack frame, where the operation for print is still waiting to happen. So it prints 2, and then that pops off. And then it prints 3, and that pops off. And then it prints 4, and that pops off. And then it prints 5, and finally that pops off. Okay, so what makes this code count up is the fact that the printing happens as the values are popping back up the stack. That is why swapping the print line to after the count up changes the direction. Here, it would print and then go down to the next one, and then print and then go down to the next one. Here, it goes down to the next one and doesn't print until it's come back from that. Okay. Turns out if you put a print line before and after, you'll count down and then count back up. You can write your own code for that. Now, what we're really going to explore in this chapter is the power that this gives us. So just being able to count up in this way, well, that's not all that significant. What matters a lot more is if I have the ability to test multiple options. Okay? And the stack gives me the ability to do that. If I have a recursive function call that calls itself more than once, well, what really happens is it calls itself once and it goes out and it does whatever work that one call was supposed to do. But when that function returns, we still remember where we were and we still continue executing from there. And so we can call again and go off with a different parameter. And then you could call again and go off with a different parameter. So this chapter is going to focus on recursive functions that call themselves more than once. Okay? And this utilizes the memory of the stack to make sure that it remembers where it was so that it can go out, test something, and then come right back to where it had been. So we're going to look at a number of different examples of different programs where this is useful to us and see how it can impact